Hello students! So now we've created our hypothesis that we think there's a relationship between the wingspan and the distance traveled. So what are we going to do next? We're going to test it. Woo! So I made 3 paper planes, but one of them actually got chewed up by Brutus, so I can't really show it. The thing that is going to be different is the wingspan in this case. So everything else should be the same in my test except wingspan, because that's my independent variable. So remember, variables are anything that's different, anything that changes. So the independent variable is the wingspan, size of the wingspan. The dependent variables then, like the effect. So this is the thing that is affected by the independent variable. So it depends on the independent variable. So they think of the dependent variable depends on something. Depends on the independent variable. So it's like the effect. Effect. Dependent. Distance traveled. Controlled variables, or called constants, are the things that are kept the same in the experiment. So if I'm testing the wingspan and how far the plane goes, everything else should really be kept the same. So the plane should be thrown the same way, from the same height, right? You should start at the same starting line. You should measure them all the same. Anything that is kept the same are constants. And there should be a lot of constants in your experiment if you want it controlled. Hidden variables are like errors, really. These are things that should have been kept the same, but were not. Because in reality, when you're throwing planes, it's hard to make them all be thrown exactly the same way, unless you had a machine that did it. So machines eliminate that human error. But in this case, we don't have paper airplane throwing machines. So you are the paper airplane throwing machine. And humans are not going to throw the plane the same every time. So we know that there are going to be some hidden variables in your experiment. So now we have the variables. And we have a couple groups in our experiment. Now I only have 2 to show you, but there were 3. Brutus had chewed 1. The wingspan increases, the plane is going to travel farther. And this is the one with the shorter wingspan. This one has longer wings. So this would be my controlled group. All right? And this would be my experimental group. So the experimental group is a group that has the independent variable. It has that difference. It has the larger wings. Okay, so if it has the larger wings, if it has that independent variable, that thing you're changing, it is the experimental group. If it doesn't, it is the control group. Think about it. If I don't have this to compare the wings to, if I don't have this plane to compare the longer wing plane to, I wouldn't know if this plane travels far or not, because I'm not comparing it to anything. But if I compare it to a shorter wing plane, then it might mean something. So the control in an experiment is needed to act as a comparison. Now I'm going to test them. So I'm going to throw them. I would just label them. You could do 1, 2, 3, or however you want to do it. I'd write it somewhere on the plane, just so you know which plane's which, because when you go, if you throw them all 3 at once, or 1, 2, 3, and then you go collect them, you might get them mixed up when you measure them. So just keep them labeled. For 3 planes, I'm going to do 10 times. And I would just line them up, since you have to do 10 trials for each. I would throw maybe the control you could do first. Then I measure how far did it go from where I started. Okay, and I'm going to measure at the nose. So I'm going to measure at the point where it lands here. In meters. Also, you're going to take the time, because we want to figure out how many seconds it took to get there. I don't think you're going to go to minutes unless you've got a rock star plane, which you might have. So we're going to go with seconds. I need meters and seconds. Okay, then I'm going to do the second one. For 3 planes, I'm going to do 10 times. So once I've collected the data, I'm recording that data in a data table. All right, and there's a data table posted on Google Classroom. There's also one on Seesaw. You can just fill that in, or you can make your own. Okay, but the data table is really a table of data. So the data is information. So why do we put data in a table? Well, it's easier to understand the data. If I just take all this data, all these numbers now, I have 3 different planes, I did 10 trials, and I recorded time and distance. So I did 2 recordings per plane. That's 60 different items of data. So if I just have all those numbers written down in no order, it's going to be very hard to interpret it. The first column should always be your independent variable. Here we have a data table. We have wingspan, we have the trials, and we have calculated our average distance and our average time. So the right side of the data table is going to be our calculations. So remember averages, how to get the average. So we would add up all the distances, right, and divide by 10, because we had 10 trials for each one. And the same thing for average time. We'd add up all the time in seconds and divide by 10. So now we have the average distance in meters and the average time in seconds. So think about how are we going to figure out how fast these planes went? Now that wasn't really part of our original hypothesis, but if we wanted to determine which one had the highest average speed or which one was the fastest, how would we do that? And then we're going to talk about how to calculate speed in the next episode. So stay tuned, rock stars. Woo!